Hello KCET aspirants, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So yes, as you all know, tests are very important to measure the level of our preparation and to understand what is our strength and weakness, right? So that is why every Sunday we conduct a mock test for your KCET Chemistry. So yes, in this one, this is the third mock test that we conducted on the chapter D and F block and coordination compound, which we completed in this previous week, right? So yes, now I hope everybody would have downloaded the question paper from our WhatsApp channel or community post and would have solved the questions, and now you would be waiting to know your scores, right? So yes, today we'll be discussing the solutions of all these questions. I'll be giving you the detailed explanation. So what you have to do, you have attempted already, right? So you have to put a correct. If it is correct, you just put a tick mark. If it is wrong, put a cross mark and write down the reason why it is wrong, okay, so that you can understand what are your mistakes, okay, and also write down this question was from which chapter. Clear? So as I told you, 15 questions were from coordination compounds and 15 questions were from DNF block. You can also mark like first 15 were from DNF block and 16 to 30 were from coordination. So you can also give you chapter wise marks to understand more about the like what is your strength over these two topics, right? So assign +1 for every correct answer and 0 mark for wrong and unattempted questions, okay? So yes students, let's get started now. Please be energetic and be hopeful that you get very good marks in this test, okay? Fine, so let us start with the first question here. Okay, the correct statement about iron is, okay, the highest oxidation state of iron in this particular compound. Let us calculate the oxidation state. So K2FeO4 is there, right? So if I calculate Fe oxidation state will be, here it is 2, here it is plus x, then we have minus 8 is equal to 0. So I can get x is equal to plus 6, right? So yes, Fe in plus 6, this statement is correct. Iron shows +2 oxidation state with 6 electrons in the unfilled d orbital. So if you see what is Fe electronic configuration, 3d6 4s2. Now Fe2 plus, if you see it is 3d6, so there is 6 electrons in the unfilled d orbital, that is also correct. The common oxidation state of iron is +3 with 5 unpaired electrons in the 3d orbital. So if I write Fe +3, right, so here 2 and here 1, so it is 3d5, right? So 3d5 if I draw, get 1 2 3 4, so 1 2 3 4 and 5. 5 unpaired electrons are there here also. So this statement is also correct. So 1, 2 and 3, option number A, okay? Next, which is colorless in water? So for colorless, what we should have? We should have no unpaired electrons, right? No unpaired electrons. So if you see scandium, what is the electronic configuration of scandium? 4s2 3d1. Okay, so scandium 3 plus will have, all these electrons will go, only argon configuration will be there, right? So here it is having no unpaired electron, so that is colorless. Correct answer is option number D. Okay, next, in which of the following both the ions are colored in the aqueous solution? Okay, so for colored we need unpaired electrons. Now if you see copper plus 3d10 configuration, no unpaired electron, we can eliminate this one. Scandium 3 plus just now we saw, so we can eliminate this one. So the correct answer will be Ni2 plus and copper 2 plus, that is option number B. So if I see nickel configuration is 3d8 4s2, so Ni2 plus will be 3d8. Okay, now if I see 3d8, then what I'll get? 1 2 3 4, so 1 2 3 4 5 6 7 and 8. 2 unpaired electrons are there. Now if you see copper 2 plus, so copper electronic configuration is 3d10 4s1. Copper 2 plus will have 3d9, right? So it has 1 unpaired electron. So both of them has unpaired electron, they will be colored in the solution. Okay, next question. All zinc compounds are white because, okay, so white means you can say colorless, okay, they do not have any color because they do not have unpaired electrons. So Zn2 plus has D10 configuration and the D subshell is full. Zn2 plus shows DD transition. If it shows DD transition, it should be colorful, right? Zn2 plus has no electron in the 4s subshell. That is a correct statement but is not valid for here. Zn is not a transition element, that also has no link with the color of a compound, but yes, it has D10 configuration which is full, and that is why there is no unpaired electron. That is why it doesn't undergo DD transition. That is why it is colorless, or you can say white in color. Okay. Next question, which of the following pairs of irons contains the same number of unpaired electrons? So you see, just by remembering the electronic configurations, we can attempt all these questions. Questions mainly come from your magnetic moment and color. Okay, so if you and to master these two things, we need to master the electronic configurations. Okay, okay. How many contains the same number of unpaired electrons? Okay. Now, Mn2 plus and Fe3 plus, if you see, these Mn2 plus is also D5, Fe3 plus is also D5. So 5 unpaired electrons are there here. So correct answer is option number B. Next, the yellow color of chromate changes to orange red on acidification due to the formation of. So if you remember, CO4 2 minus, if you give H plus, gets converted to Cr2O7 2 minus, and this can get converted in the addition of a base. So this is what yellow in color, right? And this is orange red in color, right? So this change happens due to the formation of Cr2O7 2 minus, that is option number C. Okay. Next, pick out the incorrect statement about K2Cr2O7. Okay, it is an oxidizing agent. It oxidizes H2S2S. This is correct. It oxidizes Ki2I2. This is also correct. It oxidizes HCl to Cl2. This is also correct. It gives oxygen when treated with concentrated H2SO4. Cold H2SO4 reacts with K2Cr2O7. We get nascent oxygen. Okay, not oxygen gas. Nascent oxygen is produced. Okay, so that is why this statement is incorrect. So correct answer for this question is option number D. Okay, next one. When acidified K2Cr2O7 is added to SN2 plus, then SN2 changes to, so it undergoes oxidation, SN2 changes to SN4 plus. Okay. Next, identify the product when the color when MnO2 is fused with KOH in the presence of oxygen. So if you remember the methods of preparation, first MnO2 gets converted to MnO4 2 minus, that is permanganate. Now MnO4 2 minus gets converted to MnO4 minus, that, so this is manganate, and this is permanganate. Okay, so now, so MnO2, when you fuse with KOH, solid KOH in presence of oxygen, we get MnO4 2 minus, or I can write K2MnO4 and dark green in color. Okay, so the correct answer is option number B. Next, which of the following oxide of manganese is amphoteric? Okay, so if you remember, for amphoteric, the oxidation state should be in between. Okay, very low oxidation state is basic, very high oxidation state acidic, in between it is amphoteric. So for here, if you see, manganese oxidation state is +3, here it is +4, and here it is +7, and here it is +2, right? So lowest oxidation states will be basic, the medium oxidation states will be generally amphoteric. So the correct answer for this question will be option number A. Okay. Now let us move to the next question. Why is HCl not used to make the medium acidic in oxidation reactions of KMnO4 in acidic medium? So if you use HCl in acidic medium, Cl minus gets converted to Cl2, right? So KMnO4 oxidizes Cl minus to Cl. Correct answer is option number B. Next, an example of +6 oxidation state is, this is very simple here. So if you see here, the oxidation state is +7. Here if you see X, manganese X, then -8 for oxygen is equal to -2. That implies X is equal to +6. So the correct answer for this question will be option number B. Here if you see, this is X, then we have -4 is equal to 0. So X is equal to +4. Here if you see, it is 2x, that is 2 manganese, -6 is equal to 0, x is equal to +3. Next one. Lanthanide contraction means small atomic size of lanthanide elements, small ionic size of lanthanide ions, smaller atomic size of lanthanides as compared to the transition elements in the same period, decrease in the atomic and ionic radii of the elements of lanthanide series in moving from left to right. Okay, so lanthanide contraction means along the period when we move along the period of 4f series, when we move, the element size decreases steadily, okay, due to the poor shielding effect of 4f orbitals. Okay. Now let us see the next question. Which of the following ions is colorless? Okay, so if you see gadolinium 3+, okay, gadolinium 3+, gadolinium configuration is Xe, 4f7, 5d1 and 6s2. Okay, now Xe, gadolinium +3 configuration will be what? Gadolinium plus 3 configuration will be what? 3 electrons will be removed. So Xc4f7. Okay. Now what happens? It has 7 unpaired electrons, no doubt. But you know this F7 configuration is what? Very stable. Now due to this stable electronic configuration, the stable means what? These electrons are highly attracted towards the nucleus. Okay. So they are held very tightly with the nucleus. So in that case what happens? These electrons do not participate in FF transition. Okay, so that because if they participate in FF transition, this stable configuration will disturb, right? So that is why even though they have unpaired electrons, they are colorless because they do not undergo FF transition, because if they undergo FF transition, the stability, this configuration will break and the stability will be broken, right? The correct answer is option number A. Let us see the next question. Which pair of the compounds shows similar color? So for similar color, you have to remember that Fn and F14 minus N have the same color. Okay, they too have the similar color. So now if I write Sm3 plus configuration, okay, Sm3 plus configuration is 4f6 5d0 6s2, and if I write D, so Sm3 plus configuration will be what? So I'll remove 2 electrons from here and 1 electron from here, so I'll get 4f5. Next dy configuration is what? 4f10 5d0 and 6s2. Now dy configuration will be what? Plus 3. If I remove 2 from here and 1 from here, I'll get 4f9, right? So if this is n, can I say that 9 is 14 minus 5, that is 9, 14 minus n. So these two will have similar color. So the correct answer is option number A. Okay. Next, the number of ions given by K2PtCl6. So we are now going towards coordination compound. So out of this 15, how much is your mark also? You should write it separately. K2PtCl6, so this you know Werner's theory, this one will dissociate, this one will not dissociate. So I'll get 2K plus and 1 PtCl6 complex, right? So total ions produced here is 3. Okay. Next, the coordination number of cobalt in this. So if you see cobalt, En is a bidentate ligand, means what? Each En has 2 sides to bind, right? Each En will bind from 2 sides. Then we are left with 2 bromines, right? So now if you see the total number, the total bonds formed is 1, 2, 3, 4, 5, 6. The correct answer is option number C. Okay. Next, how many EDTA molecules are required to make an octahedral complex with Ca2+? So if you know, EDTA is a hexadentate ligand, and in octahedral complex we need only 6 sites, right? In octahedral the coordination number is 6 and one EDTA can bind to all these 6. So how many will be required? Only 1 will be required. Option number C. Okay, next, the IUPAC name of the given compound. Okay, first is this one, right? We have to name the cation first. So first in the cation, what happens? We need to name the ligands first. So here it is tetraamine, here also tetraamine, here also tetraamine, here dichlorido we can eliminate, here tetraamine we can keep. Okay, after tetraamine there is dichlorido, so here also dichlorido, here also dichlorido, here also dichlorido. Okay, then we have chromium, so here also chromium is there, chromium is there, chromium is there. Now talking about the oxidation state. So if you see chromium, let it be X, okay. Ammonia ligands is 0, neutral charge, this is -2, okay, and nitrate is -1, and that is equal to 0. So X is equal to +3, right? So here oxidation state is 2, so we can eliminate this also. Now other things are same. If you see the amine spelling, AMINE, and here it is double M, right? So which is the correct spelling that you should know? So the correct spelling is double M should be there. So answer for this question is option number B. Okay, next one, okay, question number 20. Now IUPAC name of Na3CONO6 whole is, okay. First of all, sodium should be there, so sodium is there, okay. Next, hexa, this is ONO, means it is binding through oxygen, so nitrito O, the name should be nitrito O. So here you see after sodium cobalt has come, so that is wrong. Here hexa nitrito O is there, that can be the correct answer. Here also hexanitrito is there, no O is not mentioned. Here also hexanitrito, O is not mentioned. So this has to be the correct answer. Then cobalt, if you see the oxidation state of cobalt is 3, and since it is a part of negative complex, it has to be ending with ATE. So the correct answer for this question is option number B. Okay. Next one, the IUPAC name of the given compound is, okay. First we have to write cobalt. sorry, first we have to write this complex name, and complex name after it is a cation, so first it should be named, and in the complex name first the ligand should be named alphabetically. Okay, so if you see, this is chlorido, this is nitrito, this is ethane. So what should be the order? First should be chlorine, then bis ethane 1,2-diamine, and then nitrito should come third, right? So here if you see, first is chlorido, chlorido, chlorido. Here bis ethane has come, we will eliminate this option. Then after chlorido, bis ethane 1,2-diamine. Here chlorido, nitrito, here chlorido, nitrito, we can eliminate. Correct answer has to be option number C. Okay, so chlorido, bis ethane 1,2-diamine, nitrito, and cobalt 3 chloride. Okay. So let us see the next question now. Which of the following has the highest molar conductivity under similar conditions? So highest molar conductivity means the number of ions produced should be more. For that we need to draw the correct structure. So if I start with first one, that is what? Diamine dichlorido platinum 2. So if I have platinum, okay, diamine and dichlorido. Right. So here you can see there is no ion, only one ion will be produced when you put it in water. So number of ions produced here is 1. Now coming to option number B here. So tetraamine dichlorido cobalt 3 chloride, right. So if I have tetraamine cobalt 3, so first I will do cobalt, then tetraamine, so there is 3 NH3, then there is dichlorine, and then we have chloride. Okay. So now if you see, the oxidation state of cobalt is +3, here it is -2. So this is +1 and this is -1. So if I do crisscross, what I will get? CO, NH3, 4, Cl2 and then Cl. So the number of ions produced here will be 2. Okay. Next coming to the third one, option number C, potassium hexacyanoferrate 3. So Ke, K is there, potassium hexacyanoferrate. So now if you see, oxidation state of iron is 2 and this is -6. So I will get -4 and here it is +1. So if I do crisscross, what I will get? K4 Fe CN6, right. So the number of ions produced here is 4 + 1, that is 5. Okay. Now coming to option number D, hexa aqua chromium 3 chloride. So that means chromium is there and then we have hexa aqua, okay, and then we have +3 and here it is Cl minus. So if I make the complex, I will do crisscross, we will get this as Cl3. The total number of ions produced here is 4. The maximum number of ions is produced in option number C, so it will have the highest molar conductivity. Correct answer will be option number C. Okay. Next, which of the following will exhibit optical isomerism? Okay, for optical isomerism we have two types. One is MLL3, this type will exhibit, and another type is MX2 LL2 type. Okay, it's cis form, right. So now if you see that we have this one COEN3 MELL3 type, right. The correct answer will be option number B. Okay. Next one, CONH3 whole 4 Cl2 shows. So if you see this one MA4B2, right, this shows cis and trans, that is geometrical isomerism. So correct answer is option number C. Next, which one of the following complexes is an outer orbital complex? Okay, so now here I am telling you, generally strong field ligands will give you strong field ligands, okay, gives outer orbital, and weak field ligands give inner orbital. Sorry, opposite I told. One second. Okay, so weak field ligands will give you outer orbital complex. Extremely sorry for confusing you. Weak field ligands will give you outer orbital, strong field will give you inner orbital complex. Okay. Now, but if you see that here all the ligands are all strong field ligand, Cn and NH3 both are strong field ligand. In that case, you must remember nickel. Okay, nickel is an element which is also, even though it has a strong element, because of its electronic configuration, it gives you outer orbital complex. Okay, so correct answer is option number D. Okay. Next one, which one of the following is D2sp3 hybridized? Again, D2sp3 means inner, right? D2sp3 is inner orbital complex, means we should have a strong field ligand. This is a weak field ligand. These all are weak field ligand only. But here again you have to remember, with cobalt +3, okay, water acts as a strong field ligand. Okay, so that is why here if you will get a D2sp3 configuration. Okay, option number C. Next, the magnetic moment of the complexes given below are in the order. So magnetic complex, just you need to calculate the order. See, nickel here is 0 charge, so it is having 3d8 configuration. 3d8, 4 is 0. So now due to this strong field ligand, what will happen? So if I draw for NiCO4, see, for NiCO4, okay, its nickel electronic configuration is 3d8, 4s0, sorry, 4s2. Now in this compound, nickel is having 0 charge, so nickel electronic configuration will be 3d10. Means what? See, we have this one, 1 2 3 4 5, 1 2 3 4 5 6 7 and 8. Now for hybridization, what happens? For these two s orbitals pair up here. Why? Because cobalt, CO is a very strong field ligand. So the number of unpaired electrons here is 0. So magnetic moment will be 0. So definitely 1 will have the least magnetic moment. So you can see here 1 is given highest, it is wrong. Here also wrong, here also wrong. Because 1 has to be the least one. The only option that can be correct here is option number B. Okay. You can check for other options also. So if I see NiCl4 2 minus. NiCl4 2 minus, nickel charge is what? Plus 2, right? That means 3d8, and Cl is a weak field ligand. Cl is a weak field ligand, so no pairing of electrons takes place. So if I draw 3d8, we have 1 2 3 4 5. So 1 2 3 4 5 6 7 8. So number of unpaired electrons here is 2. Okay. Now if you see CrNH3 whole 6 3 plus. So chromium plus 3. Chromium electronic configuration is 4s1 and 3d5, right? Cr plus 3 will have what? 3 electrons will go, so it is 3d1 2 3, that is 3d2, right? So sorry, 3d3. So here also there will be no pairing of electrons because we don't need, already 3 empty orbitals are there, so n is equal to 3 here. Now if you see COF6 3 minus, cobalt is 3d7 4s2. Now cobalt plus 3 is what? 3d6, right? So here it is a weak field ligand, no pairing of electron takes place. So 3d6, if I draw, we will get 1 2 3 4, 1 2 3 4 5 and 6. So 4 unpaired electrons will be there. So n is equal to 4. So the correct answer for this question will be 1 2 3 4. But by just seeing this option, you can find this answer immediately. Okay. Next question, if delta naught is less than P, that means what? Splitting is less, that means what? Weak field ligand. Okay, the correct electronic configuration of D4. So weak field means small gap is there, here it is T2G and here it is EG, right? D4, 1, 2, 3 and 4. This is EG and this is T2G. So what I'll get? T2G3 and EG1. Okay, so the correct answer for this question will be option number B. Okay. Next, which of the following compounds is not colored? For not colored, what we need? No unpaired electron should be there, right? No unpaired electron. So you need remember that zinc has no unpaired electron, so definitely it will not be colored. So directly we can say option number B, because you have to remember zinc has no unpaired electrons. Okay, in any oxidation, it shows Zn and Zn plus 2 both doesn't have any unpaired electrons. So immediately we can say if zinc is there, it has to be colorless or white, we can say. Okay. Next, select the most stable complex. So here you should know that if the chelating ligands are there, okay, if chelating ligands are there, then stability will be more. What do you mean by chelating ligands? The ligands that can form cyclic rings. Ligands that can form cyclic rings, right? So here if you see, these all are chelating ligands. Here there are 2 chelating ligands, here 1 and here 3. More is the chelating ligands, more is the stability. The correct answer for this question will be option number D. Okay. So yes students, thank you so much for watching this, and I hope all of you would have done well in the test and would have given the correct answers. Please do not forget to comment down your scores so that I can understand how much you are preparing, how much you are studying, how much have you covered these 2 chapters. Okay. If you have any doubt in any of these questions, do not forget to comment down. Again, I will answer all these questions, all your doubts will be clarified. So yes, I hope all of you have completed. If not, please again I am requesting you go to our WhatsApp WhatsApp channel. Link of that will be there in the description section. Then you can download the question paper and solve these questions. Okay. So yes, thank you once again and all the very best. See you soon in the next class.